Hi, today we have Sebastian Bürgel here with HOPR. I'm Derek Rickert with Blockswap. We're here to learn about HOPR and a little bit about Sebastian.
Hey, Derek, super nice to be with you again and happy to tell you more about, HOPR privacy and what we do in the wider crypto ecosystem.
Yeah, thanks again for joining. So I know we had a chat in ETH Denver, but I thought this would be a good opportunity where we can get a bit more in depth, learn a bit more about you and what you're building. So I guess to kind of kick it off, I was hoping you could start off with maybe a simple explanation of HOPR, like you're explaining it to a 9-year-old, and we can sort of build from there.
Yeah. So when you connect to your friends on the internet, you just want to talk to them. But the problem is, on the internet, you're not just talking to them, you're also disclosing all sorts of things about you that you're not talking about, such as the location where you are right now. So literally, when you talk to your friends on the internet, you're sending along with every sentence that you send them. You're sending along your digital home address on the internet. That's what we call an IP address. And that's not cool because it allows you to track your every activity that you do on the internet. It allows to link activities across different platforms and services and, build a super personal picture of yourself that a lot of companies that want money with that and, foreign state agencies can get a total understanding of your person. And that's not great. And as we move more and more into the digital sphere and into in the crypto sphere, that's getting increasingly dangerous. So we want to, as we say, change data privacy for good. We want to make the web and Web3 a safe space by offering privacy infrastructure on the most fundamental layer of transferring data from A to B. So when Alice talks to Bob, both of them should talk and should interact in whatever digital means they use, but they should not leave this trail of metadata behind that allows third parties to connect the dots of what's going on there.
So in the context of Web3, so I know a lot of people, they're online, maybe they're using a VPN, the wallet address is already kind of scrambled. So what are you guys adding to the mix of already these ability to keep yourself private and anonymous?
Yeah, that's a great question. So let's walk through a naive use case of a user that is not using, a VPN or any other means, and then talk about what exactly are the problems of VPNs and why VPNs are actually not the solution. So first of all, if I'm, sitting in my home and using some blockchain, let's say I'm using the Ethereum blockchain, I'm using MetaMask just like everyone does. My wallet connects to one of these service providers that nobody likes to talk about, which is these RPC service providers. So typically when you use a vanilla MetaMask, it is connecting to Infura. Infura is one of the several multi-billion-dollar corporations that are giving your wallet what it needs to render the information that you seek, right? So your Ethereum balance, you start your MetaMask, it shows you how many ETH you have. It shows you the current gas prices when you're about to send a transaction. It shows you your ERC20 balances. Maybe some wallets show you your NFTs that you have on there. All that stuff that you need to really make a blockchain worthwhile, because most of us do not run our own nodes. That's not great, right? But even then, I see people who say, "Hey, Sebastian, you know what? I don't care if Infura sees my IP address because it's just my IP address. So what?" The bigger problem to me is actually linkability. Who of us just has a single crypto account? Probably nobody. Everybody has more accounts. You have your public account where you might have POAPs, right? These things that you get when you attend Ethereum events. People give these POAPs, which are kind of linked to you as a person then. And that's what POAP stands for, proof as a person, right? So, and that is something that is inherently doxed. Another thing that is most commonly inherently doxed is an ENS domain, right? So when you connect your handle to it, that's all cool. But these accounts are now by your IP address linked to other accounts. So an RPC provider knows all the accounts that you have and can link them. Your IP address is your primary identifier to connect all your accounts. And to make matters worse, not just connect your different accounts, but also connect your accounts to different offline, off-chain activities, right? Such as your email address, your social media profiles and whatnot. That's all not great. And we want to separate things that would allow others to build a better picture about you. So with the VPN, you asked specifically, what about a VPN, right? So a VPN doesn't actually add anything there. So you have to think about a VPN, like how many people are using that very VPN server that are also using MetaMask at that moment in time. And not just that VPN provider, but that very VPN server. And that's probably just you. So in terms of linkability, a VPN has an anonymity set of 1. That means you are the only one who uses MetaMask at that moment in time via that very VPN server that you're connected to. So that's why VPNs are clearly not the answer.
So I guess this kind of brings into this other thing. I know in the past you've talked about this concept of cover traffic, right? And it sounds like maybe the VPN doesn't provide sufficient cover traffic is kind of what you're getting at. Could you explain a little bit about cover traffic and then how HOPR is able to provide this sort of service to give people some security?
Yeah, it's actually 3 different things, I would say. And cover traffic is one of the 3 magic ingredients that we need to fix that very issue, right? So the first one, like the most obvious one is, okay, I'm connected to one VPN server and I'm the only one using that one. That's kind of messed up. So the first thing that we are using to improve upon VPNs is we're sending a request, and we're sending every single request. So like a request is, for example, your wallet is asking the provider, what's my ETH balance? What's the current gas price? What's the latest block number? These are 3 requests, right? Each of them is routed through different routes. So instead of sending one request, we're breaking that request down into indistinguishable looking packets, which are being sent to the server. And not just do we break them down into these packets, we're also mixing these little packets up, right? So we have these multi-hop routes, and as the data packets are hopping along the path, we're mixing them up with other indistinguishable looking packets. So nobody knows where it came from and where it goes to. So linkability here is basically the crucial ingredient. And then the third one is what you mentioned, which is cover traffic. So we basically want to ensure that at all times that there are sufficient other packets around which make it useful to mix anything. Like if there is no other traffic, like what will you mix it with? So there's this concept in Mixnet of cover traffic, which is kind of fake traffic, you could say, but it's looking indistinguishable from real traffic that you as an Ethereum wallet user, for example, are actually creating. And yeah, so cover traffic is adding extra noise in terms of these packets. So we have these indistinguishable looking packets, and then we have these multi-hop routes and can very quickly switch paths through this mixnet for like a great level of anonymity. We have actually stronger anonymity in the mixnet than a VPN or even Tor. So some people might be familiar with Tor. Mixnets provide way stronger privacy than even Tor.
Got it. But thank you for explaining that. So I know I'm kind of jumping around a little bit here, but you were kind of alluding to cover traffic, so I wanted to get into it.
Yeah.
In your docs, you have all of these kind of like poetic examples. I remember one where you're talking about how a leaf in a forest is indistinguishable from other leaves, but you put a leaf on the ground in the middle of a room and all of a sudden everybody notices it and it's all you can see. And I thought that was just such a great way to kind of get a picture of what this cover traffic is. Could you give a little bit of an explanation? I think you were before, but this concept of the paradox of anonymous routing.
Yeah, so sure. You want me to get into this cover traffic or anonymous routing?
I was hoping to get into anonymous routing, but I'm happy to get into cover traffic as well. Yeah.
So basically the idea is that the whole idea that we want to establish here is I want to talk to Derek in a digital world without Derek knowing where I am. If I want to disclose who I am, that's fine, but I don't have to, right? So in the example that I was kind of alluding to earlier, the Ethereum wallet and this RPC provider, the RPC provider doesn't need to know who I am, right? Like they don't need to know which city I am right now. Like why would they? So basically what we want to establish is a means to have what we call at least sender anonymity, right? So you don't need to know who I am. In many cases, we also want recipient anonymity, right? So I don't necessarily need to know who you are or where you are. You just need to serve me, Ethereum data. I need to ensure the integrity of the data, but we should be able to do so in an anonymous fashion. And the next ingredient is we don't want third parties to understand who is talking with whom. We don't want third parties to eavesdrop, and not just eavesdrop in the sense of the data itself, which is of course encrypted, but we also don't want third parties to understand who is talking with whom, right? So this is kind of a strong requirement, and that is going way beyond the kind of typical security considerations. Like when you start a new WhatsApp communication with somebody, WhatsApp chat, right? It says this conversation is end-to-end encrypted, and congrats, right? But many times I can infer so much about what's going on by just knowing that you are talking to a certain party, right? So, I mean, if you let's say you only know one, like you know who your partner is talking to. Let's say you are in a relationship and you know that your partner is talking to a divorce attorney, maybe that reveals more than you need to know, right? So, you don't care exactly what that conversation is about, but the fact that that conversation happened reveals a lot. Like that is a drastic example of how pure metadata, which party is communicating with which other party, is really disclosing a lot.
Well, it sounds like there could also be a lot of misunderstandings with the inconclusive data as well, because in your example with the divorce attorney, maybe she's looking into it for her sister or her mother or something, and I jump to conclusions, and it can cause a lot more issues by either not knowing the full piece and knowing just little bits and pieces of it.
100% agree. And that's just one example of, we leave this trail of metadata behind, like accidentally. Like the internet was not designed with privacy in mind. Like the internet was designed so that, you can run a web server and I can, access some resources on a web server. The internet was not really designed for running global scale social networks and commerce on it, right? And that's a lot of that what we're dealing with in the crypto ecosystem to fix that. And that's what we want to contribute with HOPR, to build the basic infrastructure that allows us to interact with each other in a safe way by providing privacy in the most fundamental layer.
So if you're suggesting that the internet is inherently not private, which I would agree with, it's not private, and HOPR is providing this layer of privacy, do you ever see a situation where maybe somebody wouldn't want that amount of privacy, or do you think that everything should kind of put up this veil of privacy now that there's new tools available, and we should kind of live in an anonymous world?
So like if there were no trade-offs, I would say we should have that level of anonymity for everything. We will later on get into like why there's no free lunch. Mm-hmm. But I think you should, by default, have privacy by default. You should have privacy for absolutely everything. If you voluntarily choose to disclose certain information, then that's fine, and that's absolutely okay. So, for example, if you want to disclose your name, your identity, or your location, that's totally fine. But you shouldn't be forced to accidentally do that just when you interact with somebody else. I shouldn't be forced to accidentally disclose all my Ethereum accounts to Infura just because I want to know what my ETH balance is. Like that literally makes no sense. And that is harmful. And I think people will get harmed because of that very information of metadata. So yes, I think privacy by default is an absolute necessity, and we should all work towards the tools that enable that.
So without HOPR, how would somebody even go about getting this level of privacy, or is that even possible?
It's really tricky. So one thing that, in the crypto space, many people are advocating for is like run your own node. And it's cool, right? So big shout out to our friends at DAppNode. Get a DAppNode, by the way. There's a super cool branded HOPR DAppNode. Awesome, like run your own
Amazing
nodes.
DAppNodes.
It's very cool. But here's the issue, right? You connect your MetaMask to your own DAppNode that runs at home, and you can be sure that the data that you're being fed is correct. Your node is verifying the integrity of the whole chain, including the data that it feeds you. But here's an issue. Like, if you're using your own DAppNode, you're probably the only user of your DAppNode. So let's say you have 3 accounts. You have your ENS account, you have your personal savings account, and you have your random airdrop farming aping account, right? And there's certain reasons why you want to keep these 3 separate. But you're making transactions from every single of these 3 accounts through your DAppNode. And again, now we're going like one level lower, like how do peer-to-peer networks such as Ethereum, Solana, Polkadot, whatever, how do these systems work? Well, there's one peer that connects to another peer. And your DAppNode IP address, again, the IP address is a unique identifier for you. So on this peer-to-peer network, we can see where transactions originated from. And it's actually people who do that, and that was something that I actually learned in Denver. I found it like really shocking, actually. I didn't know these services even exist. So I talked to a guy who works for a like data provider, which looks at kind of individual transaction level data and where it originated from. So there's services who do this kind of surveillance as a service already today. And, this is something which allows them to, again, link these 3 accounts because they know these 3 accounts always came from the same DAppNode. So, yeah, probably that is the one which is currently connected to their hardware wallet or whatever, even if you've physically separated devices, right? So even if you do absolutely everything right, you use a hardware wallet, you might use a multi-sig, and you use even separated devices. Even in these cases, there will be others who will be able to link your accounts. So it's a long answer to saying no. It's freaking tough to separate your accounts right now. A VPN is not the answer. Running your own node is not the answer. Both of these are solutions that get you closer, but it's not good enough. It's not good enough for what we want the Web3 to be.
So is there a way now, if somebody is saying, like, I wonder what kind of data that can be tracked through my wallet through these transactions, are there any like tools that I could go out there today and see what's being tracked out of my data?
Yeah, so there's something that we actually built to make this real fun. It's called DERP, which stands for Dumb Ethereum RPC Provider. It's dumb because it does basically just one thing. It could exploit you real bad, like all other RPC providers. End of disclaimer. And but it doesn't. So what it does, so you can go to derp.hoppernet.org, and it's basically a proxy for another RPC provider. I think we actually on mainnet connect, I guess, to Infura. I'm not sure. But basically what it does is you can connect it to your wallet, for example, MetaMask, and the website will render all the requests that are being sent to that RPC server. Right? So you can see on DERP, it's actually really educational if you want to understand what your wallet does behind the scenes. You can see every single request that it does and all the metadata that it sends along. For example, it sends along, obviously, your IP address, but also browser information. So for me, you would find out that I'm using Linux, that I'm currently in Zurich, Switzerland, what sort of like browser I'm using. That is all information that can be used to fingerprint me as a unique Ethereum user and link it again to my other accounts. So pretty messed up. And yeah, you can use, I suggest you use DERP and find out like what your wallet is doing. You also see, like how many requests your wallet is using, and even, like very weird stuff. Like at some point I've seen that there was, I don't want to dox the wallet because, I think wallets try, but there was something really spooky. My wallet was locked, but it was, last time I used it was connected to DERP. So I started my browser, and this browser wallet was making a request despite the fact that my wallet is actually still locked. So that's pretty weird, right?
Yeah.
So you're being tracked before you actually consciously use the product. So yeah, check out DERP.
Yeah, that's interesting. No, I came across DERP, and I have to be honest, the thought went through my head. I'm like, I'm reading all this stuff about the data privacy. Is this really the time where I want to upload more of my, upload more of my information to be tracked, but I guess it would be helpful for me to kind of know what's happening and why it's happening.
That's one thing which kind of like gets everybody off track, right? And that is actually something that is actually fascinating. You know, this dropdown in MetaMask where you can connect to a different network, like you can connect to like, I don't know, Gurley testnet or like, some L2 or whatever. Like the pure fact that we call this a network is mind blowing. Because actually you're not connected, like when you choose a different entry in a dropdown, you're not connected just to a different network. Primarily, you're connected to a different server, right? You're connected to somebody else's server, right? And that name doesn't ring well in a Web3 space, but it should make us aware, right? So the fact that we say we're connected to a network obfuscates the fact that we're actually just connected to somebody else's server who can data harvest the out of us while we're using our Ethereum wallets. That's not great. So that's what we want to fix. And yeah, that's what we're working on to fix that on top of HOPR, and maybe we can talk about that in a bit.
Yeah, of course. So I had a question, and then we can get into that as well. Is like, so I know with HOPR, you guys are saying anybody can run a node. You have these amazing HOPR DApp nodes, and I was curious, what does that process look like? What does it take to actually become a HOPR node operator?
So right now, if you want to join the HOPR network, we kind of artificially like restrict the growth rate of the network. And that's just because we don't want things to crash and catch fire all the time. We want to grow the control speed and improve the scalability of the HOPR network. So right now, if you want to run a HOPR node, you install it, you can run it on your own server. So the HOPR D node, like that's the HOPR daemon, similar to Bitcoin D for the ones who have been running a Bitcoin node. You can install it on your own server as it should be. It's free and open source software. You can download the source code from our GitHub and check it out. The other option is what you mentioned. You get yourself a HOPR DApp node or a HOPR Avado. It's like a fork of DApp node, and install that. Then the next thing you do, you need to stake at least 2,000 HOPR tokens. So that is currently I can't calculate. It's like under $100. So it's not, no, it's a bit over $100, but it's not much. And then, so this is still like, we could have a large number of nodes. And to constrain the size to like really people who are eager to run nodes, we have these community NFTs that we give out. So if you're active in the HOPR community, there's like certain activities that we do to earn these NFTs. So what we do, for example, is we do like some surveys, we do like some puzzles that people solve, and we give out some NFTs. So basically, with these NFTs, we kind of like we give you kind of a score, and when you're high enough on some waiting list, then your node gets activated.
So it sounds like to run a HOPR node, you need to get involved with the community, start contributing, and then you get approved, and you can get access to run these nodes. That's great. So when somebody is running a HOPR node, what exactly are they running? Like what's going on there? What's kind of like the technical angle of HOPR? How are they making this happen?
Yeah. So from you as a user, if you don't want to understand what's going on, you install the software, you fund it with a couple of HOPR tokens, and you configure it once and you forget about that, right? And then, you collect some funds after a couple of weeks or months. Like, it will have more HOPR tokens collected. So that's, like the least involved explanation. Now, what the hell is it actually doing? So you are running a HOPR node. That means so HOPR is not a blockchain, right? So many people are like, so it's running a validator. It's like, yeah, economically it feels somewhat similar to a validator, but we're not an L1 blockchain. We're not an L2. We're data relay infrastructure. So what you're doing is you're relaying data packets, right? So we're also not a mixer or something. Also, sometimes people get that wrong. So is HOPR a privacy coin? Like, can I do money laundering? No. Like, I love privacy, but unfortunately, HOPR does not help you with money laundering. Sorry, guys. So what you're doing is you're sending data packets to establish privacy for other users. So I might get a data packet from Derek, and I forward it to Alice, right? And for doing so, if I do that correctly, I get rewarded in HOPR tokens. And that is, on a high level, so you're basically relaying HOPR packets.
Sorry, I have a question here. How do you verify that people are relaying it correctly?
Yeah, that's a great question. So we have at the heart of HOPR is what we call proof of relay. And again, it's not like proof of work or proof of stake or something like that, but it's basically a bottom-up kind of guarantee that you only get paid if you forwarded a data packet correctly. So let's walk through this example, right? Sebastian receives a packet from Derek and forwards it to Alice. So what happens is that I get this packet, I decrypt it. In a header, I extract some information, and afterwards I can see, oh, I'm supposed to send it to Alice. Also from the header, I get a secret key that only I can derive. So I have a private key on my node, and I get this packet from you. And only with my private key can I derive kind of a payment key. Let's call it payment key, right? Then I forward the packet to Alice. If I did not modify the packet, I can try to be, smart about it and like tweak the packet and say, hey, I around with the system, right? If I around with it in any way, Alice will not be able to derive her key. And that's a problem because Alice will send me a key half back. And only if I have access to both keys, I can overlay these two keys and unlock my payment. So I really like this mechanism because it is a very elegant means to combine header information, which ensure the integrity of the packet, with payment information on the other hand. And yeah, this combination is what makes HOPR safe and prevents value extraction.
Okay, interesting. So this is all going on sort of behind the scenes. This is all a very quick transaction, right? This is happening.
Absolutely fast. Right. This packet exchanging is like it's sub-second. It goes super fast, and yeah, it's obviously automated, right?
Yeah. And is this available only on Ethereum for Ethereum transactions?
So here it gets very interesting, right? So HOPR is kind of infrastructure that is incentivized. Like I kind of alluded to that when I said that you unlock a payment when you forward your packet, right? And, when you get a payment that, is probably settling on some blockchain, I already said we do not run our own blockchain, but it's currently we are running on top of Gnosis chain. So Gnosis chain is not so popular. It's great for us. It's very reliable. It's very stable, and we can just settle on it for very cheap. So we have a payment channel implementation that already makes us very scalable. But even beyond that, it's just, kind of nice if you are a small, young, low-cap project to run on a cheap chain. Now, so this is basically what is happening on the infrastructure level. Now, however, if you want to use HOPR, right? So if you want to use HOPR for private Ethereum transactions, you can use that for any chain. And in fact, we are right now building a product called RPCh, which stands for RPC over HOPR. So basically, you can connect to like something like Infura from any EVM wallet for any EVM chain. And basically, your wallet is not just directly sending the request to the server, is sending it through multiple hops in the HOPR network to the server and back the same path, right? So by doing so, you receive privacy. You fix this issue, which I introduced initially. Now, this doesn't have to be on the same chain. This doesn't just work for Gnosis chain. You can use that on Ethereum mainnet. You can use that for like totally different chains. You could theoretically, even though we haven't built it yet, like you could use that for Solana transaction. You can use that for Cosmos transaction or Bitcoin transaction if you so choose, right? So HOPR is agnostic infrastructure that you can use for whatever use case you want to and is not chain specific.
So yeah, it sounds like this can be used in a lot of different ways. Yeah, you've come up with a lot of examples now, but you could put adapters for each chain. And I'm guessing protocols could probably work this into some of their methods as well, right? Where just by default, some things can start to develop as more of a private operation.
I absolutely hope so. So I would hope that, maybe in like, I don't know, 1, 2, 3 years down the line, HOPR is going to be exposed as a default endpoint. How like Ethereum nodes or any other nodes, like allow you to connect via HTTP or WebSocket. I hope that there's a third way, which is like going via Hopper, right? So you don't just have, HTTP and WebSocket, but you also have some Hopper connection by default. And also, like, as you mentioned, even on a consensus layer, right? So we actually did some research last year, which was pretty interesting, on digging into privacy issues of the proof of stake Ethereum, of this thing called the Beacon chain, which has a pretty nasty privacy issue. Like, without getting too deep, basically what it allows me to do is, if Derek runs an Ethereum validator, I can find his IP address, right? I can link his pub key to his IP address by observing what is called an attestation. Like, once every 32 blocks, you create an attestation. I observe that long enough, eventually I will find you, and I will find your IP address. Now, why is that bad? Because also in Ethereum, unfortunately, I know when you get to attest a block. And if I'm right after you, what I could do is I could snipe you, right? I could do a super, super, super targeted DDoS attack, which costs me literally next to nothing. Just take down your, DApp node that runs in your home with residential internet connection, which is really no big deal to take down. You're only down for, maybe 20 seconds. Then it's too late. Your block is gone. Your slot is invalid. All the high value transaction, all that juicy MEV rolls over to my block, and I make a profit, right? That's an issue. And that's something that I hope to solve, soon with Hopper as well. The reason why we don't do it just yet is because, getting something in the Ethereum consensus layer is kind of hard. Latencies are pretty tight, so that's a bit tough. But that's something that absolutely must be solved.
It sounds like you're kind of putting something forward that's a little bit different than like the PBS that's currently being discussed, right? Instead of being able to say like, hey, there's a marketplace and people can purchase or, get access to each one of these blocks, you're saying it should be random, that it should be private and people shouldn't know who's going to come next.
So there is actually efforts to do exactly what you just described. Like, it's not PBS. There's something which is a bit further out, and it's called single secret leader election, SSLE. And even in that case, even if I don't know when is your turn, right? That's something that should be fixed. I agree, and I'm a little bit surprised that it hasn't been fixed before. But whatever. Even then, I could just troll you, right? So if I know you are Vitalik.eth, right, and Vitalik.eth is running a validator, I can just troll him, just because. And, we've seen how in crypto networks people troll just because. So we do need privacy even then, right? So even then, you should not be able to find out on what IP address I do run an Ethereum validator. So we should separate kind of transport information from economically relevant information.
Got it. Thank you. So I guess I have one more question for you. It's like, does Hopper have a backstory? I'm curious how you came up with this idea and where it's going from there.
Yeah. So I mean, I've been working in the Ethereum space since like late 2015, and have been working first as a technical consultant. Of course, there were this great ICO wave, building shit tokens for whoever needed it. Greatly entertaining times. And we then started building actually, not just tokens for whoever needed it, but wanted to build truly decentralized applications. I'm actually really interested in building this hardcore resilient applications. I find it fascinating. And we're looking into, well, how do we actually go about building that? And like, we can send money, cool. But if you think about it, sending money is not the most exciting thing you can do on the internet. So the next thing is, what else do you do on the internet? You store data. Okay, cool. Like, there were great projects already back then, IPFS, then there's Arweave in the meantime, and a bunch of other storage, and so many more. That seemed to have been handled well. What else do we have on the internet? We have compute, right? So there have been, like, even though it's not so much in the forefront right now, there have been a bunch of projects that do decentralized compute. I guess with like all this AI craziness, we will see more decentralized compute going forward.
I guess hearing you talk about all this, I do have kind of a question about the future of Hopper. And it sounds like this could be something that would be really amazing to be integrated directly into a wallet, or right where people are at this time. Is that at all on your horizon?
Yeah, totally. So, I mean, we really think that crypto wallets should be way more private. Crypto wallets are our entry gate to the Web3 wonder world. And, that entry gate shouldn't just data harvest it out of everyone. So to protect you there, we are building RPCh, so RPC over HOPR, as the first truly private RPC provider. And you can actually use that right now. It's free, so it's maybe a little bit quirky to install right now, but you can check out, go to access.rpch.net. So access.rpch.net, you can get like your free access token, and with that you can just use it. And again, works on any EVM chain with any EVM wallet, which is kind of cool. And yeah, ultimately we're interested in, we think many people in the crypto space are great, but we think data harvesting doesn't deserve a place on this, new universe that we're building here. So if you are working on a crypto wallet, we want to make that less quirky than it is right now. So we want to integrate RPCh into wallets with an SDK for that to make it real simple. So that's what we're really after. And maybe like on the Outlook side for the HOPR protocol, that's kind of cool, because I would say RPC services are probably one of the few actually proven business models in the Web3. So everyone knows that, everyone is too lazy to run a node. Let's face it, so am I personally. So I know that I have to pay for one of these providers. If you have to pay for them anyway, why not choose one that actually doesn't data harvest your users and provably cannot data harvest your users? That's what we're aiming for with RPCh.
So RPCh is a way for people to interact anonymously today with the blockchain.
100% correct. Yes. Currently, we're limited to EVM blockchains, but looking to grow that to some crazy L2s like Cosmos, Polkadot, and beyond. That's absolutely on our roadmap. Yeah.
That's great. Amazing. Well, Sebastian, thank you so much for joining me today. I appreciate you taking the time to explain HOPR and a little bit about Web3 privacy.
Thank you, Derek, for having me on, and all the best to you.
All right. Bye.